In the last class, we studied about the magnetic field around a straight conductor, and we also talked about the magnetic field if the conductor is in a shape of a circular loop, isn't it? So, what did we study about a straight conductor? Whenever there is any electric current which is flowing through a straight conductor, so how can you determine which is the direction of the magnetic field? If you hold your right hand thumb along the direction of the electric current, you will be able to determine the direction of the magnetic field. Opposite to this, suppose if I give you a conductor which is in a form of a closed loop. So suppose if it is folded into a circular loop, you have to do the same thing. Again, put your thumb along the direction of the arrow, along the direction of the electric field. Look at this. What is happening on the left hand side? If you see this picture, onto the left hand side, just put your thumb along this arrow. Along this arrow. See, this is arrow going like this. So put your right hand thumb. Your fingers will be rolling inside like this, from inside to outside. So that is the direction of the magnetic field. When you now in this towards the right, what will happen? When you come towards the right, now your thumb will be pointing in the downward direction because the current is going like this and coming downwards. So again, if you roll the fingers, so what will happen? Then your fingers will again be rolling, 4 fingers will be pointing from inside to outside. Okay, the magnetic field direction will be from inside to outside the loop. Fine. Now what we do is, see, this is the red line shows and the blue arrow shows the direction of the current. So the current is getting reversed because now it has been the straight conductor has been converted into a loop. Now the direction of the current is going like this, in a circle. So when he is putting his right hand in here, where are the fingers rolling? From inside to outside. When he is holding the pipe or the conductor like this, again the thumb will be pointing. So again the 4 fingers are rolling inside of the loop to outside. See, inside the loop to outside. So if you put this loop, if you make this loop lie down on the ground, what do you see? You see all the lines will come out of this loop, and from the bottom they will enter inside the loop. See, from the bottom all the lines are entering inside the loop. I already told you that all the magnetic field lines will be emerging out of the north. So here, where are they emerging? They are emerging from the top. So this point is the north and this point is the south. Now you have 10 loops. So what will you see? You will see that all the field lines will again come out from the top and go inside, out from the top, and they will be entering inside from the south. So if you see, it is behaving like it's something like a bar magnet. The arrow shows that they are coming out in this direction. Okay, the conductor has been rolled into a loop. This pole is the north pole because all the magnetic field lines will always come out from the north, and the bottom one is the south here. Now if I ask you what is the direction of the magnetic field, what will you do? Again, you will take your right hand, put your fingers along the direction of these lines. Okay, then the thumb is going to show you the direction of the north. Now also, as you see in the picture, you can try putting your right hand. Your fingers will roll towards you. If you put your right hand, the direction of the thumb, which is towards your right, is going to show you. This end, the right end, is the north end, and the left, this end, is the south end. This is what we covered in the last class. Today we are going to cover the force through a current carrying conductor. You will also study that if you have magnetic field as well as electric field both operating on a conductor, then both together can actually move the conductor. Move means physically it can move the conductor. Okay, so you see this picture here. What I have done is I have taken a conductor. So this AB is a conductor. This is a horseshoe magnet. Okay, which is north. You can see N written over here. This is north and this is south. I have connected this conductor, only the conductor, through a circuit, which means that I will be passing current through the circuit. Okay, so understood? There is a conductor, current is flowing through the conductor, which means yes, I have electric current with me. Now what I need? I also need magnetic field. So how do I supply the magnetic field? I will bring a magnet close to this conductor. I have electric field also operating. I have magnetic field. How will you determine the direction of the conductor? Look at, so what, suppose if this is a magnet, okay, this is like the magnet that I have shown you in the picture, isn't it? Now let's say the top one is the north. Okay, so this is your magnet that was shown in the picture, and this is a conductor. I'm holding a conductor here. So if this is a magnet, the top end is the north end, the bottom end is the south end. Clear? Top one is north, bottom is south. This is a conductor. So I will keep the conductor like this. If I show you the front, it will be like this. Okay? So I'm showing you the side. So the conductor is like this. Okay? Now from north to south, which is the north? From top is the north. So this is the downward is the direction of the magnetic field. So magnetic field lines will always travel from the north to the south. So they will go in the downward direction. This is the conductor in which electric current is applied. So I'm putting the conductor like this. Okay. Suppose this blue end of this pen, this conductor, this blue end is connected to the positive end of the battery, and the other end, the other end is connected to the negative end of the battery. Okay, so from positive to negative the current is going to flow. Now I told you that when both are applied together, they are able to push the conductor physically from one place to another place. So how do you determine the direction of that push? All of you will raise your left hand. As I speak to you, please raise your left hand. When you raise your left hand, okay, all of you are able to see my thumb, my hand. This is my left hand. So first hold your thumb like this. This finger, the index finger, is like this. So both are perpendicular to each other. One is going up, one is going in this direction. So both are perpendicular. Now you're going to put your three other leftover fingers, three fingers again in the perpendicular direction towards you, like this. So one on the top, one like this, and three fingers as you see the screen out of the screen. So this rule is called as Fleming's left hand rule. F is the force on the conductor. Force means in which direction will the conductor be pushed, physically pushed. So thumb will be telling you in which direction the conductor will be pushed. This index finger is your magnetic field direction. M is your magnetic field. In which direction is the magnetic field acting? And these three fingers will be telling you the direction of the current. C is the current. Force, F for force, M for magnetic field, and C is for current. This rule is called as Fleming's left hand rule. The magnetic field will be going from top to bottom. In the downward direction the magnetic field was going, and the current was going from the blue end to the white end, means from here inside, from the front to inside. So you know two fingers already. So first you hold the magnetic field. This is the magnetic field finger from top to bottom. So your index finger will be pointing from top to bottom. See, from top it is going bottom. This is a magnetic field line finger, isn't it? Second finger, you know the direction of the current. Okay, the direction of the current was from outside to inside the board. As I am looking at the board, from outside, because this pen was like this. This was the blue end. The conductor was like this. So this was the positive end. Inside was negative end. So from here to inside. So the current is going to go inside. So which is the current finger? These are the current finger. They have to point inside. So what will you do? Like this. So these fingers will be pointing inside. This thumb is going to give you the direction of the conductor, the direction in which the conductor will be moving. So where is the direction of the conductor? This side, this side. So this was the conductor was like this. So the conductor will be moving this side. The thumb is pointing like this. So the conductor will be moving this side. So now I am holding the setup again. This was the initial setup, this was the conductor. So where is the conductor going to move? This side. From here, if the conductor was here, it is going to move inwards, inside towards the bar magnet. Is this clear? Now suppose if I reverse the direction of the magnetic field, something like this. So the south is up, the north is down now. South is up, north is down. This conductor remains the same. This is the positive end, okay, and the white one is the negative end. It is the same. But what I have done is I have just reversed the direction of the magnetic field. On the top is the south, bottom, so something like this. This is south, this is north now. Okay, if you are able to see the board like this, this is south, this is north. Okay, and this is the conductor. So this is the conductor. So hold your fingers again. So it is going to go like this. Okay, first my index finger towards the top. Now look at this. Again the current was from out to in. These current fingers will be going like this, inside. Okay, if you can see, inside. This is the magnetic field finger. This is the current finger which is going inside. Where is the thumb showing? The thumb is showing in this direction. So that means the force on the conductor will be in this direction. If I hold my hand like this and the conductor is like this, then the conductor is going to go out. When I change the direction of the magnetic field, the direction in which this conductor moves also changes, isn't it? Suppose here, let this be initial. Let this be what we did initially, north and south. So again like this. Okay, if you can see, this is the north, this is the south. Now if I invert the conductor, so this is connected to the negative end of the battery. The blue end or the black end of this is connected to the negative end of the battery, and the other end, this end is now connected to the positive end of the battery. So now in which direction to which direction the current is going to flow? The current is going to flow from in to out. So first hold your magnetic field finger. All of you raise your left hand. First of all, show me your index finger from top to bottom like this, because this is the north, this is the south. So the magnetic field will always go from north to south. So first take your left hand, okay, put your index finger down like this. The current is coming from inside of the board to outside, from inside to outside. So these fingers will also come from inside towards outside like this. So where is the thumb showing? The thumb is showing towards that direction, isn't it? So when I change the current or I change the direction of the magnetic field, the direction in which the conductor moves also will change. It will get reversed, and you saw how it got reversed. And this is what is Fleming's left hand rule.